So we're going to draw the Lewis structure and the VSEPR diagram for the iodine oxopentafluoride. The Lewis structure cannot explain the three-dimensional molecular geometry, which is a little bit complicated than the basic Lewis structure. Let's start with the Lewis structure for IUF5. First, you need to add all the valence electrons together. So IUF5 has 48 valence electrons. So the structure would be this is I, F, this oxygen, again fluorine. So we're going to distribute 48 valence electrons like this. Should have 48 valence electrons. So this is the Lewis dot structure for the IUF5. As you can see, there are 6 electron groups around the iodine atom. So this is 1, 2, 3, 4, 5, 6. So the molecular geometry would be octahedral. So we can draw the 3D shape like this. So iodine at the middle, and fluorine and oxygen. These three go vertically. So we're going to distribute the atoms like this. And some other fluorine right here. Third fluorine atom. Then the fifth fluorine atom. So, and all angles would be 90 degrees. You can see there are no lone pairs, and this is symmetrically the angles would be 90 degrees. We are going to draw the Lewis structure and the VSEPR diagram for the hydronium ion. The Lewis structure cannot explain the three-dimensional molecular geometry, which is a little bit complicated than the basic Lewis structure. Let's start with the Lewis structure for hydronium ion. So there are 8 valence electrons for the hydronium ion. So you can draw the molecule like this. So first oxygen right here. We are going to draw the Lewis structure and the VSEPR diagram for the hydronium ion. The Lewis structure cannot explain the three-dimensional molecular geometry, which is a little bit complicated than the basic Lewis structure. So this is the hydronium ion. So there are 8 valence electrons. So we can draw the Lewis structure as follows: 3 hydrogen bonds and 1 lone pair right here. So let's have a look at the VSEPR diagram. So as you can see, there are 4 electron groups. Therefore the structure has to be tetrahedral. However, there are 3 bonding pairs and 1 lone pairs. Therefore the structure would be trigonal pyramidal. So we can draw the structure like this. The oxygen atom right here, and hydrogen. Another hydrogen bond is going away. So you can tilt this a little bit like this. It's a positive ion, cation. So, and typical tetrahedral molecule angles would be 109.5, but in here, because of this lone pair, and this lone pair pushes these hydrogen bonds, resulting 107 degrees, which is less than 109.5 degrees. And as you know, lone pair bonding pair repulsion is greater than bonding pair repulsion. So that's why this has 107 degrees angle.